So let's approach it the same way we would filling out our notebook. What's the objective? This exercise. Right. Well, it's got several objectives in the method. Let's see, let me look at your copy here. Here we go. Yeah, same objectives. Well, it's got several objectives, but ultimately, our objective is to determine the rate law for a food dye plus bleach reaction. Right? So what happens when you put bleach in a food dye? It decolors it, right? It destroys what we call the chromophore, the molecule that produces the color is destroyed by bleach. And it happens over time. It has a rate. So what's the rate law going to look like? It's going to have a K value, correct? And then it's going to have concentration of dye with its order, reaction order. And then we're going to have bleach. Actually, instead of bleach, we're actually going to put it in terms of the active molecule in bleach, which is sodium hypochlorite. Sodium hypochlorite. Okay? So in order to write that, we need to know this one, and that one. Okay? Pre-lab questions, all right. Well, the first pre-lab question talks about determining the molarity of a 5% sodium hypochlorite solution. So that's a dimensional analysis problem. We have pre-labs, questions. Let's see, maybe I'll do this one. So if the household bleach is 5% sodium hypochlorite by weight, okay, that means mass of sodium hypochlorite per mass of bleach. How do we find out the molarity of that? The molar concentration of sodium hypochlorite. Well, think about what is molarity. It's moles per liter, right? So we need volume in here. This is the mass of sodium hypochlorite. This is the mass of the solution. That's where the density comes in. So 5% equals 5 grams of sodium hypochlorite per 100 grams of solution. Right? That's what that means. Percent, parts per 100. It's 5 parts per 100 parts. Okay? So you're also given the density, 1.08 grams per milliliter. Right? So that's grams per milliliter, grams of solution per milliliters of solution. Okay. So we can figure that out. We might run out of time. Of course we will. Oops. Yeah, I'm recording. Okay, so 5 times 1.08 divided by 100 is 5.40 times 10 to the minus 2 molar sodium hypochlorite. Right? No, it's not. What is it actually? It's grams sodium hypochlorite per milliliter of solution. Okay, we're not done yet. Correct? 5.40 times 10 to the minus 2 grams sodium hypochlorite per milliliter of solution. Okay? How are we going to convert that? We need moles per liter. That's milliliters, right? So we need liter of solution. We need liters here, milliliters there to cancel. So 1 liter is 1,000 milliliters. Right? That takes care of the solution volume. Now we need moles of sodium hypochlorite. How do you do that? Molar mass for sodium hypochlorite. We need grams here and moles here. So how do we do that? Sodium is what? Well, we look on a periodic table. 23.00 for sodium. How about oxygen? 16. How about chlorine? 35.45. (74.45 grams per mole is the molar mass of sodium hypochlorite. There we go. Now that should get rid of grams here, grams there. That's moles per liter, right? All right, so let's get our calculator out. Saying I've already got this number in my calculator, so I'm going to multiply it by 1,000 right here and divide it by 74.45. So I get 0.725 molar sodium hypochlorite. Okay. Now, that's pre-lab question 1. What's pre-lab question 2? How many grams per liter of sodium chloride are required in order to prepare a solution with a concentration equivalent to this solution? So we need sodium chloride that's equivalent molarity. But we need to know how to make it. How many grams of sodium chloride, pure sodium chloride, per liter will make you that concentration? Okay, now why do we need to do that? Well, the method says we're going to have a high concentration of sodium hypochlorite in the beginning, right? Because it's going to be the constant concentration. Buried in this term and this term are combined to give us the pseudo rate constant. Like that. See, that's what we've done. But we need to be able to find out what this one is. So you actually need 2 concentrations of sodium hypochlorite to do that. Well, when you set up your experiment to run with 1 concentration of sodium hypochlorite, then you set it up to do it with another concentration, you add half as much sodium hypochlorite to the solution, but you make up the difference with something other than water. What you need is something that has the same ionic strength as sodium hypochlorite, but without the activity of sodium hypochlorite. So sodium chloride is a good choice. It has no oxygen in it to cause the discoloration of the dye. So you want something with this the equal molar concentration. This is what we're looking for. 0.725 molar sodium chloride. Because for the second round, at half strength bleach, we're only going to use half as much of this with the second experiment. Right? This is initial rate stuff. And we're going to make up the difference with the rest of the volume is going to be this. Okay? So we just need to say, all right, how much of this do we need per liter to make up that molarity? Well, if this is moles per liter, then it already said you're going to make a liter. So we only need to find out how many grams is that many moles. Right? So moles we're going to cancel here and leave us with grams. So we need the molar mass of sodium chloride. There's sodium, there's chlorine. We just need to remove the oxygen, correct? Yeah, 5845. Does that make sense? Right? We took away the oxygen, so it should have a smaller molar mass, which it does. The difference is 16. So that times that should give us the answer. 0.725 and then 58.45 times is 42.4 grams. Sodium chloride per liter will give you the same molar concentration as that. And what do we have? One more? Yeah, one more. What's the percent of sodium hypochlorite by weight for a liter of bleach that is 0.8 molar sodium hypochlorite and has a density of 1.09? This one just works this problem in reverse. Right? So instead of going this direction, number 3 goes backwards. Only it starts at 0.8 instead of 0.725. Okay. You can do that one, can't you? Just run it backwards. You want to convert moles per liter into grams sodium hypochlorite per milliliter of solution, and then use the density to go back to this. What's the percent? So you want to get back to here. Now, what do you think it's going to be? Is it going to be greater than or less than 5%? If it starts off at 0.8, it's probably greater than, isn't it? If it starts out at a higher molar concentration, then the percent should be higher. Okay? Now, the one that we're going to use in the lab is 6%. And that's one of those handouts I gave you. Talks about the determination of molarity for 6% bleach. Yeah. But when you do your decolorization procedure, you're going to count the number of drops of bleach that you put in there. And then we're going to weigh the number of drops of bleach to find out what is the mass of drops that you put in. And then based on that and the percent composition of the bleach, we can tell how many moles of bleach we actually put in there, how many moles of sodium hypochlorite. That's what that concentration, that calculation is all about. Okay. Well, let's see. I got 2 minutes. And then there's another handout that talks about what do you actually do with the numbers. Let's see, that's theoretical, that's theoretical. We're going to use the blue dye. Notice that I've got the red crossed out. When we have lots of students in the class, we can have one group doing red and one group doing blue. We're just going to use the blue dye. And the blue dye has already been mixed up. It's been diluted and it's ready to go. So you can write that into your procedure as this is how it was prepared, but it's the instructor did it for us. That type of thing. And then there's the wavelength that we're going to be using a spectrophotometer and measure the absorbance at that wavelength, and you're going to see the absorbance go down like that as the bleach does its dirty work. Okay. So if you have any further questions, we can Zoom a session, or you can call me or email me or whatever. But be sure and set up your notebook to be ready to do the experiment. At least to do the mechanics of the experiment. We can talk about what to do with the data afterwards.